Morning.
Morning.
Morning to you.
The birds are
Blue. Look, we just try to get it to rhyme, right? So good morning and welcome back.
Welcome back to my channel.
Welcome back to my channel, everyone. Thanks for subscribing and stuff. Right, I'm gonna go back and do a react video on that, and I'm just gonna be like, what was I thinking? I was thinking it was funnier when you could see my face. Oh, I need to get a face cam. Anyway, we took a quiz yesterday. It was pretty stinky. I haven't finished grading out this class periods yet. Yeah, but it was pretty stinky. Like, you're even admitting, you're like, yeah.
Oh yeah, I know mine was stinky.
Yeah. So here's what's gonna happen next week, kind of early next week, Tuesday, Wednesday-ish. We'll do a requiz, okay, and we'll try it again. To get us to that point, to get us ready, I'd like to kind of go over some of the major things that seem to be of concern in Unit 13 so far. So that way you've got some more practice on it. We'll continue on with the new stuff as well. Roll it all in, okay? All right, so the first thing that it looked like you guys had a bit of trouble with was factoring by grouping. All right, so factoring by grouping came to us from day 3. And I'm going to grab one of the items from day 3 in order to factor, maybe one that we did not do as an example in class. Here we go. So if you haven't turned in your day 3 yet, you may find this one in this assignment. Hopefully this helps you out. Okay, factor this thing. To factor by grouping, step 1, the easiest step, is just to make some groups. To make some groups, just put some parentheses, leave yourselves plenty of space inside those parentheses. Make sure they're separated with a plus sign. Always a plus sign. Don't even worry about what the thing I gave you to factor has. Now we're going to fill each group, and the best way to fill each group I found is just to go in order and to split it up fairly evenly. Each situation is different, so be prepared for that setup not to work and for you to have to go back and try it again. Okay? So I'm just filling in. Done. Now I need to do greatest common factor for each group individually. Okay? So I'm going to look at the factors here, and I'm going to split it up into as many different factors as I can get away with so that I can see what all I have. I'm doing just the first group. I'll do the second group in a bit. All right, looking at the first group, I've split them all. It is a 14. It is a 14. So positive 2, negative 7. Thank you. Typos. Yeah, so it's the 2's and then x. Anything else? And another x. Yeah, so my common factor is 2x squared. And then in parentheses, I'm going to write all the stuff that was left over. So in this term, 5x. And in this term, negative 7. This plus sign falls down. And then I'm going to repeat this with the other group. Now, 21, I had a couple different options. I could have gone positive 3 times positive 7. I could have done 1 and 21. But I picked negative 3 and negative 7 because I wanted a match to this negative 3 right here. And that was the only reason why I picked a negative 3 there, was because I was looking for a match. Okay? We are harmony.com right now. eHarmony. We are eHarmony with our factors. We want to get some matches. Okay? Swipe right on that. That's it. Look, I don't use any of these sites, so I just quote commercials without knowing what I'm doing. We're not saying that you use the sites either, okay? Just
Or do
making
you?
sure that's clear.
There it is.
Oh, don't call anyone out now.
Yeah, Johnny.
I use Christian Mingle.
Farmers only.
And now from here, it should be fairly clear which things these two terms have in common. I saw a few items where these two weren't matched and it looked like sheer panic because like it just stopped and moved on to the next one. If you get to this point, these didn't match, you may want to go back here and break these into more factors to see if you can find more things that they have in common. And if that doesn't work, then come back up here and try a different combination of stuff in each group, okay? All right, and so now this is factored. Do, 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 do. That's factored, and everything is happy. Okay? The other thing that I saw that was a concern came to us from day 2, which was, bless you, the sum and difference of cubes. I did write these on the board for you because they're a pain in the asymptote to memorize. I took the word out of his mouth. That's what happened. But they look like this, and again, I'm not demanding that you have these memorized anytime soon, but if you write them out each and every single time you're going to use them, the chances of you remembering it for test time go up. So I do recommend that you have these in your notes, that you practice writing it out each and every time, so that way you can get familiar with it. From day 2, let's do this one. All right, so the trick on this is this portion on the left. You want to get something cubed plus or minus something cubed, and that'll tell us which one of these patterns we're using. This one is definitely a plus, and so my question is, can we rewrite 64x cubed as something cubed? What do I need to multiply to itself 3 times to give me 64? 4, okay. And then I multiply x to itself 3 times to give me x cubed. What do I need to multiply to itself 3 times to give me 216? Yeah, I don't know either. Totally go to your calculators. It's going to be bigger than 4.
What was the number?
216?
I just put it in the note.
Yes, but you need to make sure that the index is a 3. Otherwise, you're going to be taking the square root. 6. Which makes this A and this B. I'm using the plus, so it's the top one. I'm just going to rewrite this, but instead of A, I'm going to write 4x, and instead of B, I'm going to write a 6, and everyone's going to be happy. A plus B, A squared minus A times B plus B squared. Cleaning up a little bit, trying to write the correct numbers and failing. Related, we had difference of squares, but most of you feel comfortable with that. It's the same idea, it's just smaller. Now, the next portion where we struggled was when we took something like this and I told you solve it. Okay. When you had to take this and solve it. Some of you went down to here, which is fantastic, and so we had equals 0. The trick from here would be to use the zero product property. That is the property that says when you got a bunch of things multiplied together that equal 0, each of the things that you're multiplying can be set equal to 0. And this allows me to figure out what values of x I need to have so that I will end up with a 0. The left side of the equation was really easy for, I think, everyone to get. The right side of the equation is where I saw some stumbling, if you use this method. So you can either factor the thing, it's not going to factor. Or you could complete the square, this has to be a 1, and if it's not a 1, you have to divide everything by that. Oh my God, that's a disgusting fraction. Or you go to the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Those are your only options to solve this thing. You factor it, this one won't factor. You complete the square, the first number has to be a 1, and if it's not, you have to divide, it makes fractions and gross. Or use the quadratic formula. For what?
ASMR.
ASMR. No, that's not what this video is. Or we come back to this one and we think about it a different way. What if, instead of seeing this as a sum of cubes, which it totally is, instead we see it as just a standard equation, let's isolate the variable. Any addition or subtraction to remove? Yeah, the 216. So let's get rid of the 216. Any multiplication or division to get rid of? Yeah, the 64, so let's get rid of that. Okay, I have a gross fraction, but y'all have inspires that will reduce the fractions for you. So go ahead and do that at this time. Negative 3.3, let's keep it as a fraction because I want to show you something. So can you get this fraction reduced, please? Either the TI Inspires, or if you're wanting your smartphone because you're like, I don't feel like using the Inspire today. Desmos will reduce it as well. The Desmos app, which is a free app, hashtag not sponsored. Or you could probably Google just simplify fraction calculator or something like that. So whatever method you're using to simplify your fractions, give me this fraction simplified, por favor. Don't know why I'm bobbing my head up and down like crazy chicken up here. This would be hilarious if I had the FaceTime. You'd see me like. Negative 27 over 8. Beautiful, thank you. Now I have a question for you. Slightly related to this, but not written down. If I had an equation that was x squared equals stuff, how do I get rid of that square power?
You'd multiply it.
Square root.
Oh, yeah.
So if I have a cube power, what could I use to get rid of it? Cube root. To get rid of a cube power, take the cube root. Hang on to that thought, put it in your back pocket. We're going to use it again in like 3 minutes, okay? To get rid of a cube power, you take the cube root. And now I have this thing, which doesn't look any better. It looks gross. Here's the neat thing, is that when it's an even power and you have a negative in there, it's automatically an imaginary number. That -1 turns into an I. But if it's an odd index, it's a 3 or a 5 or a 7 or an 11 or something, negatives in the radical are just fine, because if I multiply an odd number of negative numbers, it's going to give me a negative number. For example, I have -1. -1 times -1 is?
1.
Positive 1.
Yeah.
Positive 1 times another -1 is?
-1.
It's a negative. Anytime you have an odd number of negatives multiplying together, you're going to end up with a negative number. And a cube root is asking, what number do I multiply to itself 3 times to give me the thing inside? But that's a fraction. Yes. When you have a fraction inside of a radical, any kind of root, you can break up the radical to the top part of the fraction to the bottom part of the fraction. And so now we're gonna take each portion of the fraction by itself. Cube root of negative 27. What number do you multiply to itself 3 times to give a negative 27? 3 times 3 times 3, but that's a positive. I want a negative. Negative 3. Negative 3 times negative 3 is positive 9. Positive 9 times negative 3 is negative 27. Cube root of 8. The number you multiply to itself 3 times to give you 8. 2. And that's it, you're done. I'll allow either way on that upcoming re-quiz thing, test thing that we've got coming up. Okay? The trick to this was remembering to undo a cube power, you take the cube root. To make today's item work, you're going to have to remember that fact and realize it can go the other way. If I have a cube root, what would I use to get rid of a cube root? Cube power. I got rid of a cube power with a cube root, and so to get rid of a cube root, I should use a cube power. Hang on to that thought. Come to number 2 on today's notes. That's notes that looks like this. Number 2. We're going to isolate the radical first. Is the radical by itself, or is there an addition or subtraction hanging out outside of it? No addition or subtraction, but there is a
2.
2 by multiplication. How do you
You
undo
divide.
multiplication? Divide, he said. Divide both sides by 2. That gets rid of it here. Cube root of 3x minus 5 equals 5. How do you undo a cube root?
Cube power.
So I'm going to raise everything to the cube power.
I thought I said cube power, not pig.
No,
But it's cube.
cube,
power.
not cute.
No, I know that's what I thought I said.
The cube power next to the cube root make them cancel each other out. I'm left with just the stuff inside of that radical symbol. And now that's an equation that's easy to solve. Right? Add 5 to both sides, divide by 13, we done? Okay, you all can finish this out on your own. Because I want to look at number 4. Oh, hello, random phone call, which I will decline for now because y'all are more important than my phone. My apologies for it ringing. Let's look at number 4. Number 4 looks complicated because not only do I have a cube root, I also have a cube power inside of the cube root, and I've got x's on both sides of the equation, and I'm suddenly wanting to have a panic attack. Relax. One thing at a time. Is the radical by itself? Yes, I don't have additions outside of it. I don't have multiplications or divisions outside of it. So how do I get rid of a cube root?
Cube power.
Cube power. Here's the stuff inside of the radical. Do not change the stuff inside of the radical. And then here is the right-hand side with the cube applied. Now from here I have a couple options. I could collect things all to one side so that it's stuff equals 0.
You can do the
And I could check to see if it's a sum or difference of perfect cubes. And then I could factor it. And one of the equations would be easy to solve, and the other one would be this quadratic that I couldn't factor, and I'd have to probably use completing the square fractions or quadratic formula. The star. Or I could pretend that this was just a regular equation and try to get all the x's on one side and then isolate.
Yeah, you can do the plus 27.
Yeah, that's what I'm going to want to do. Add 27x cubed to both sides. And then I can divide by that 54. Okay, I'm going to need help because I have no idea what 486 divided by 54 is.
It's 21. I'm just kidding.
It's 9. How do you undo a cube power?
Cube root.
cube root.
3.
So x equals the cube root of 9. Can we simplify that any further? To what?
3.
3? So you're saying 3 times itself 3
Oh, no,
times is
no.
9?
No, you can't.
Yeah, I can't,
Yeah.
I don't have a whole number, so it stays just like that. Easy enough? Yeah. I want to show you number 6, not because we're doing anything super crazy with it, but because there's suddenly 2 radicals. And I want to talk you through this a little bit. Your first instinct might be to try to add those radicals, or in this case, subtract those radicals together. But we can't. They're not like terms. They're not the same kind of radical. They're not the same kind of radical because the stuff inside of them is different. Okay, so they can't hang out together. So instead what I'm going to do is I'm going to isolate one of the radicals. I'm going to move this radical over to the other side of the equal sign to get him out of the way so that I can look at just this one here. And I've picked that one to move because moving him makes him positive. And I don't like negativity in my life. Try to surround myself with positive numbers. And then we're back to our normal question. How do you undo a square root?
Square power.
Square power. So I have stuff that looks like this. The left-hand side now should be fairly comfortable and easy. The right-hand side, though, looks weird because now we're no longer just multiplying a square root by itself. We now have something that we're multiplying to the square root. Hi, later. Thank you. When we have something we're raising to a power, and that something has a bunch of factors to it, it's a bunch of stuff multiplied together, this is when you are allowed to distribute the power. You may not distribute the power if the operation between the things is addition or subtraction.
So,
Because we have the operation between the 3 and the square root of stuff being multiplied, I'm allowed to apply the power to everything in there, okay? 3 to the second power is 9. 9 times. Now the power and the root are going to cancel each other out, and I'm left with just the thing that was inside the radical without making any changes to it. From here now I can distribute, collect all my x's to the same side of the equal sign.
9x plus 9.
Mm-hmm.
And then you can do the minus 2x.
Mm-hmm.
And you can x equals negative.
Right? Like really, really ridiculously simple. It was getting it to that point that was a bit of a challenge. Let's look at number 1 before we jump down and figure out what the heck that means.
7/3.
Yeah, right? As a power. As the exponent. 7/3 is the exponent. We'll talk about what that means in a second. I want to finish up our examples here. Is the radical by itself?
No,
No, I got stuff around it. Do I have any addition subtraction to get rid of?
the plus 6.
The plus 6, let's do it. Okay. Do I have any multiplication or division?
Oh, just multiplication.
I've got the multiplication of the 1/4. How do I get rid of a fraction in an equation?
Multiply.
Multiply by? By the denominator.
The least common, or the.
If you had more than one fraction, yes, you could multiply by the least common denominator. That would get rid of
Yes.
all of the fractions.
Oh, okay.
I only have one, so I only need to worry about it one. Great insight. Thank you.
Because I don't know back.
Yeah. No, you're
over-
right.
Where is it?
I want you to notice something about the notation that I'm using. Here I'm multiplying by a big number, and here I'm raising stuff to a power. When I'm multiplying, the number is large, about the same size as the rest of the main numbers in my thing. When I'm raising to a power, the number is small and kind of floating above its head, okay? So make sure that you're making that difference in your notations because it's a very big difference. So now I have the fourth root of 2x equals 16. How do I undo a fourth root?
You multiply. No.
Yeah, it's like, I'm not really sure. Okay, let's go back a step. How do you undo a square root?
Square power. So the
How do you undo a cube root?
so it'll be to the power of 4.
Cube power. So how do you undo a fourth root?
Fourth power.
Yeah.
I don't know if I'm multiplying.
It's okay. 2x equals whatever I get when I do 16 times itself 4 times. I don't know. You guys have calculators. Do it. Tell me a number. Go.
6 times. Oh,
We're doing 16 to the fourth power. Yes.
Oh, wait, no.
16 times 16 times 16 times 16.
65,536.
65,536.
Wow.
Talk
It's
about
okay.
big
You'll have
numbers.
calculators because these numbers are ridiculous. Now what? I want x by itself.
You divide by 2.
Divide by 2. When I do, I get
32,768. Oh, that's a big number.
it is. If you took computer science with me last year, these numbers might look familiar. Powers of 2? No? Oh, it's all right. You're like, I need that memory space. Delete that file. All right, before we go into number 8, so we can get number 8 on this example page to make sense, come back to your line sheet of paper. I'm going to write on the back because I need a bit of space. You can write wherever you have room. You'll need about a quarter page, maybe less. All right, in order to handle number 8, where we've got an exponent that's a fraction, let's talk about what that even means. So here I have a thing, it's being raised to some power, and that power has a fraction to it. This is absolutely no different from writing it as a radical, where the thing that we've been raising to the power is now our radicand. The denominator of our exponent becomes our index, and the numerator of our power becomes the exponent of the radicand. Okay?
So the 3 would be the index and then the 7 would be the exponent?
Yes.
Oh, okay.
Okay? Let's do practice of this one before we jump into 8. Okay? Because 8's a little complicated. Okay, we're going to do this in the context of a solve. Looks crazy. So we're going to exchange this thing, rational exponent, for this thing, a radical. Here's my radicand, the stuff inside. What's the index of my radical?
3. No. 5.
The denominator, always the denominator. What's the power of my radicand?
3.
The numerator, always the numerator. And now we're back into the realm of what's simple to think about. How do you undo a 5th root?
5th power.
5th power. Bless
Bless
you.
you.
1 to any power is going to be 1. How do you undo a cubed power? A cubed root. And then from here, it's super simple to solve.
Minus 1. And then 1 over 2. Wait.
No. Minus 1, minus 1?
Yes. Oh, it'll be 0. Oh, okay. That's like 1 over 2. Like, no. 'Cause
No.
it'll be 0.
Yeah. All right, let's go look at number 8. Get your calculators ready because the numbers are going to get big really fast. I know, right? Number 8. Let's rewrite that rational exponent, the thing with a fraction in the exponent, as a radical. Here's my radical symbol. Here's my new radicand. What is the index of my radical?
3.
Always the denominator.
Then the 7 is the power.
And the
Exponent.
power is the numerator. It's always that pattern. Is the radical by itself?
No, you need to do minus 2.
Yeah, I gotta get rid of the 28 by subtracting it. (156 minus 28).
156 minus
28, yes ma'am.
120.
How do you get rid of a third root?
Third power.
Yep. I need 128 to the third power. It's gonna be something big. Something ridiculously big.
2,097,152.
Okay, I'm really,
So 2, 0.
97152.
yeah. Thank you. I'm really bad when you say out all the places, but you just give me the digits. It's a big number. And guess what? We're not quite done, because how do you undo a 7th power?
You
7th roots.
oh,
So I need to know what is the 7th root of that number, 2097152. I had students last period go to their, because they were using their phones, go to Google and type in like a root calculator or something. And they found a way to put this into the website and it spat out an answer.
Was my password?
I don't know. Desmos might be able to do it. But remember, you're not going to have access to your phones or the internet on quiz or test. So I recommend that you figure out how to do this on the Inspire so that you can do this.
I found it.
Did they figure
It's on top of the little triangle.
Oh, on top of the little triangle?
Yes, it's you control and then it's that, and then you can enter a number.
So on the Inspire, control this little carrot top, and then it gives you
I
a
didn't
little
enter
square
the
right
number.
here, and then you can enter it.
Wow.
Okay? All right. So go ahead and enter that number and tell me, what is the 7th root of 2,000,000?
Yeah. Wow.
You don't believe it? Take 8 and multiply it to itself 7 times.
Oh, no, I missed it.
Oh. Okay. You agree with it now? Oh, you typoed a number somewhere?
Yes, I put the cube root instead.
Wait.
Oh, oops. Cubed root instead of 7th root. Like what?
Yeah.
Oh,
Yeah.
yeah.
And then this now should be really easy for you to get solved the rest of the way.
The whole number. And then it's 8.
And then it's 8, right? That's it. That's all I had.
Bye.
Tomorrow, Monday, the next time we're together
Bye.
for our next episode, shall we have a preview? Spoiler alert. Spoilers. Next episode, we're doing this stuff.
The least common denominator, right?
Fractions in the grossest way. You're going to have to be able to get common denominators.
So there's the trinomial.
You're going to have to factor. You're going to have to multiply and add and subtract and cross multiply and all sorts of fun things. We'll do that the next time we're together.
4, you're cross multiplying, right?
We'll show you.
Oh, okay.
Bye.